Okay, so good evening, everyone. Welcome to today's Asset Colloquium at TIFR. In fact, today's colloquium is somewhat a special one. This is the joint colloquium organized by Vidyavardhini College of Engineering and Technology from Vasai and the Technical and Professional Activities Committee of the IEEE Bombay section. And of course, TIFR Asset Colloquium. So thanks to Dr. Vikas Gupta, HOD of Electronics from Vidyavardhini College, and also Dr. Sunaina Jadhav, who were instrumental in bringing this talk, and along with Dr. Aran Patel from IEEE Bombay section. Of course, now today's topic is the role of engineering and science disciplines in building robust and scalable AI systems by Dr. Bhushan Jagyasi from Accenture Advanced Technology Centers in India. And welcome, Dr. Bhushan.
Thank you.
Is no more a buzzword, and I think it's actually delivering solutions to many problems in a diverse number of areas. And so it's nice to have Dr. Bhushan talking about this particular very interesting topic. And as you can also see on the Zoom platform, we have large number of students, undergraduate and postgraduate students from Mumbai space. I think that is a nice welcome kind of thing to look at. And I think it's good that they will be very much benefited by your talk. And without taking more of your time, and let me straight away invite Dr. Sunaina Jadhav to formally introduce you, and then we'll start with the rest of the proceeding. Thank you.
Good evening all. It gives me immense pleasure to introduce our speaker today. Dr. Bhushan Jagyasi is currently leading the innovation agenda and sustainability in AI practice of Accenture Technology India. He has headed various initiatives in Accenture AI practice, which includes speech analytics, utilities, and natural resources. He is keenly interested to contribute towards societal and sustainability initiatives. Dr. Bhushan has earlier worked as head, customer behavior and data science at Pristine Infotech, where he contributed in pricing and revenue optimization with consumer-directed approach. In earlier part of his career, he has worked as a research scientist in the digital farming group of TCS Innovation Labs India, where he built up and headed a R&D team focusing on agriculture sustainability. Dr. Bhushan holds a PhD from the Department of Electrical Engineering, IIT Bombay in 2009. He has been a recipient of IMIT's India TR35 Young Innovator Award in 2010. He has experience working in different domains, including agriculture, retail, accessibility, and assistive technology. Thank you, Dr. Bhushan, for sparing your valuable time and sharing your knowledge and experience with us. Thank you so much.
Thanks to the team, Dr. Sunaina and Dr. Vikas Gupta and Dr. Satyanarayana, for giving me this opportunity to present my thoughts in front of students and other faculty members from different disciplines. So before I start, I would like to all of you to maybe enter about your department, which discipline you are from, so that I'll understand the distribution and I'll structure my talk accordingly. So if you can use your chat and just type your department name.
I think most of them are from, I understand, from Sunaina and Dr. Vikas Gupta. They're from the basically circuits branch, electronics and telecommunications, and
okay.
Some of us are from the instrumentation and electronics.
Okay, great. So as you would have heard, right, my background is also from electronics and communication. I'm BTech and MTech in electronics and communication and electronics, and then I did my doctorate in electrical engineering. And you might be wondering, what was my journey, to enter into the field of artificial intelligence, and what are the use cases that we work on, what kind of industrial applications one can work on. So I'll focus my talk on those lines to make you familiar more towards industrial applications of artificial intelligence, which will cut across multiple industries, and it will require expertise from different disciplines like electronics and communication and IoT, as well as sustainability or environmental sciences and so on, right? So be it from whichever discipline you are, there is a way to bring in innovation and utilize AI. And let me share my screen, and then we can start the discussion.
Yeah, it's visible.
Okay, great. Let me just put the video panel on the other screen. Full screen. Are you able to see the big screen or the?
Yes, yes, we can see your screen now. Yeah.
Okay.
Yes, perfect.
Okay, all right. So let me get started on the industrialized AI. So I'll touch base upon what is the role of engineering and science in building robust and scalable AI system. So I'm part of Accenture technology centers in India, and I'm working there as a AI scientist, cutting across different industries and technology areas. So I will divide this talk into three parts. One is I'll start with a short introduction. Most of you would be familiar with AI as such, so I'll not spend too much time there, but I will talk more in terms of what is our approach in building AI applications at scale. Then, since I was part of the speech analytics area for a few years in AI practice, so I would like to talk about my journey there. And since most of you are from electronics and communication, you would empathize with how signal processing plays an important role, and what kind of applications we can build, how you can leverage your domain expertise to make the AI more robust and scalable. And finally, I'll talk about the sustainability AI use cases. Sustainability is very close to my heart, as I worked in for many years in the area of agriculture, and I'm now leading this agenda of sustainability by utilizing artificial intelligence. Okay, and then we'll talk about a few use cases which you might be again interested in. So very quickly, let's little bit talk about what is artificial intelligence, and I'll just give you my point of view on that as well. So we all have seen several industrial revolutions, right? It started with mechanization of power looms, etc. So more mechanization to automate, to basically speed up the production. Then it was more towards utilization of the electricity to again enhance the speed of the production to go towards the mass production. Then there was an era of industrial revolution 3.0, where computing played a major role, computing, communication, and ICT technology, and so on. That's the era which we saw, I think, a decade ago. It went on. There were lots of applications from using ICT and computing, and we all have seen this very closely. And then came the era of more and more digitization. Okay, by utilizing IoT, wireless sensor networks, and also artificial intelligence and machine learning, blockchain, and these kinds of emerging kind of technologies. It also includes quantum now. It's moving towards that. So this is where we are today, and you will see most of the applications that involves scientists and engineers from different disciplines working together, right? It's just not AI scientists will come up with application which will break the things, right? But you also need support from domain expertise. I'll talk more about that subject in this presentation. But what is really artificial intelligence, right? And when it emerged, so it goes back to 1950s, where Alan Turing talked about Turing test, which is the intelligence test on the machines, whether machines can think as intelligently as any human being, right? So that was where whole discussion on this started, and then there was a development of neuron or a perceptron, which imitated human brain. Okay, and then there were some ups and downs in emergence of AI. We saw a second wave of AI boom in 80s and 90s, where we saw neural networks and backpropagation algorithms getting invented. And post that, again, there was not major of computing advantage or the data advantage which was available. Hence, we did not see a very big boom in 80s and 2000. But now what we are seeing is the third boom of AI. And we'll talk about why it is really now. Okay, and we are seeing algorithms, very deep neural network algorithms getting invented, and they are actually working, right? In speech, we have seen the transition from hidden Markov-based traditional models to deep learning-based end-to-end speech recognition systems, right? But this is my view on how is artificial intelligence different from natural intelligence? Would we be able to really reach there? The intelligence capability of the human brain, right? So if you have observed, in meditation, or if you are practicing that meditation, apart from the brain, what we are trying to imitate, right? Which is like a network of neuron and the electrical signals going in that mesh, and they're making the decisions based on the observations that we see, and they learn in the process, right? The way child picks up the language, it's really amazing. The way child starts correlating some certain word with an object or an image, that's really fascinating, right? All that happens in the human brain, but I believe that there is something more than just a brain, which maybe sits in our head, but there is also a mind, right? Which is like which is across us. When we meditate, we realize different layers of consciousness, right? Can machine have such layers of consciousness going from brain towards mind, and then towards other layers like ego and so on, right? That is a quite philosophical kind of a discussion, but we'll keep our discussion limited to what machines can achieve and what machines have achieved today, which is like we are trying to replicate more and more towards human brain. And the way human learns from observation of the environment, can machines learn as good as them? And how can machine help, right? So is it one way or other? Can the machines really replace humans in all the activities, or they will just augment our activities and help us in doing certain jobs more faster? Like calculators, computers, they emerged. Have they replaced us? Yeah, to some extent. In some tasks they have, but now human is free to think about something more advanced, and we are just using them as tools, right? Okay, so what is really AI, and why it is emerging now? So as we have seen, how human mind works, or the human body works rather. So we have different senses, like we can see, we can touch, we can hear, and so on, right? And we can comprehend those information points in our brain, and we can act. And based on our action, when we perform certain action, we get some feedback, okay, whether this action was correct or incorrect, from the environment or from our mentors, right? And this feedback helps us to learn. Okay, so machines also can do almost exactly same, right? The learning part is very important. It should keep on learning and augmenting. So this is the foundation of it, artificial intelligence. But why is AI emerging really now? We've seen Turing test happening in 1950, right? It has been 60, 70 years now. Why it is really now? So it is because of these dimensions, these parameters. One is we have a large amount of data, which is acting as a fuel to train artificial intelligence models. Data is very important for machine learning and AI. So unlike human brain, we need hundreds and thousands of examples of the same class to understand, to classify, right? A child may be able to recognize the difference between dog and cat maybe more easily, right? With only fewer examples. When they will see a variance of it, they will be able to still manage that variance, right? But not machines always, right? They need a very large data set to be trained. That's the bigger difference. And this is enabled through the social media, the amount of data that we have today for images, for speech, for in documents and text, and also the structured data. That's at a very big scale. So this is possible because of the data. Then we have seen the proliferation of AI products and solutions. There's lots of AI use cases that has emerged, more and more focus of AI. There is a low barrier of entry also. You'll see that lots of AI models are available, and maybe I'll also touch upon this topic, democratization of AI skills. AI skills have become, pervasive. You'll see lots of models available on, GitHub, which are pre-trained, and you can just have a quick start. Within 1 or 2 days, you will have model working for detecting 1 out of 1,000 different classes. So it's very easy to detect a person now and distinguish that person from some other objects and so on. Right. And there is an exponential growth in terms of, computing, and high performance computing is there. And all these factors are helping us to make AI more feasible and realizable today. So this is a context on AI, and we will basically, we have heard artificial intelligence, machine learning, and deep learning. And we have seen AI existing, from 50s onward, but machine learning, it was more towards structured data, and it's a bigger discipline rather. And inside that, we have seen the models which are limited to the deep learning, neural network based deeper models. They form in the class of the deep learning. And the main difference between traditional machine learning and deep learning is we don't do lots of feature extraction today. Okay, we leave that feature extraction part to the models. So for example, in speech applications, what used to happen 2 decades ago is each and every word was broken down into different phonemes. When I say hello, it was broken down into hey, love, 2 phonemes, right? And now what happens is a single word goes as a text, HELLO, okay, and a waveform goes as an input. And it is left up to model to learn from that waveform and understand the patterns, understand what are the features, and give us the output. So that's the major difference which has happened as a shift between the machine learning approach traditionally and what we see as a very big deep learning based models today. And there are a couple of more slides which I would like to cover before I take a pause and move to the next topic. Again, between conventional computing and AI, what we are seeing is AI is more probabilistic, like a human brain. You will take a decision associated with certain probability. You'll say that, okay, it is going to rain today with 90% probability, right? You will not say that it is going to rain. In conventional computing, what used to happen is it used to be programmed, right? If this and this happens, you get this, which was deterministic. Now it is more probabilistic, and AI is more learning-based kind of approach. And on different areas, where we are working on, these are different technologies. We'll talk about few technologies like speech today, and a couple of more integration of different technologies. And then there are some industry applications. So AI is applied almost all industry spaces, as you can see here on the right hand side. And you would have heard about different advanced learning theories like active learning. Keep on adjusting the labels as you predict. Federated learning, where data is not shared but it resides on individual nodes, and the learning happens in a distributed kind of a fashion. Reinforcement learning, which is more like human behavior, right? Where you don't have right or wrong examples, you just have a penalty and rewards to train. So this is a technology and the industry landscape that we have. Okay, let me take a pause here.
Actually, yeah, Dr. Bhushan, actually some kind of a black patch that comes on the top of your screen. Yeah, okay, now I think it's good. Yeah, but now again it comes, so you may have to just pull the band somewhere away.
This one?
Yes.
Okay.
To pull it down or move it to some other area.
Okay.
Blocking your title of the slide.
Okay.
Yeah, so great.
Thanks for that. Yeah, I'll stop. I'll take a pause here. If there are any questions, maybe we can take them.
Okay, I don't see any on the chat. Okay, there's a question. So this is Alak Ray. It says, can you say how Bayesian formalism affected AI?
Yeah. So I think yeah, I also actually used Bayesian kind of approach earlier, and I have seen it works with even with a small data set, right? But in AI, you usually require a very large data to keep on continuously train. You may arrive at Bayesian optimum kind of a Bayes optimum result using AI as well, uh, and there might be some work, but I have not seen much correlation. But maybe it can be used based on the amount of data that is available in your system.
Yeah, in the earlier, if I can add a comment, in the earlier systems where you kind of build production rules using that, build like expert systems, and so the entire evidence for a particular, the case is to be based on the Bayesian calculus. You actually calculate the probability of each of those actions. But as you said, now once the data kind of is the one that was ruling now the world.
Yeah.
So I think these techniques have kind of give away for more of a computational learning systems.
Correct. Yeah. So you need to know all this a priori probabilities to design those systems. Yeah.
Okay. Other questions? Any quick questions to the speaker? If not, then anyway, there will be enough time at the end.
Yeah.
I request the speaker to move forward.
Okay, let me proceed ahead. So what I will do is I'll skip a few slides looking at the time because I wanted to cover some use cases in the end, which would be more interesting than the regular discussion on AI. So let me just proceed further and let me start with on the speech analytics. Okay, so as I was earlier, talking about, so in the speech signal, when you observe the waveform, it appears something like this, and this is a waveform of word hello. Okay, so you can see how it varies with time, and it can be like compressed in but many formats and so on. But typically, we utilize a wave dot waveform to analyze it further, which gives us an array of byte array. Okay, and in speech system, the starting point is you convert the speech signal in time to Mel frequency substral coefficients, which appear something like this. It's like transforming from time domain to the frequency domain. So if you understand the nitty-gritties of Fourier transform and DCT, it's advantage for you to enter into this area of speech processing because a lot you can do by that, understanding. Because you'll understand the science behind it. It's better than training the models without having that kind of a knowledge. So that's always useful. Then there are different applications to it, like and typically in our journey, we start with the crowdsourcing application, which helps us to collect a lot of training corpus, and it also helps us to curate the data by some data labelers if it is required for generating the training data. Then the different areas of work include the voice command classification or keyword spotting problem, which is a trigger word for Alexa, Google, and so on. Okay, which can be utilized to trigger a device on or off, or it can also be utilized for some applications in home appliances to turn on, turn off. I'll show you some paper of ours in this area on voice command based media player. Then domain-centric speech to text, and also accent-centric, as well as dialect-specific speech to text is the area of research. And in India, there are large number of languages, as we know, and there are different accents in each language. Even if you just consider English spoken in West Bengal with respect to how is this spoken in Maharashtra or Tamil Nadu, everything varies from region to region. So to detect it very accurately, you need to have a good distribution of data. So that's very important area of research. Then text to speech, it helps in the virtual agents as well, or talking systems, and it should happen with emotions or sentiments. That's an emerging area of research. And speaker diarization is an area where you separate the speakers when there is a conversation like this kind of a meeting or a call center. We'll see one use case of this on the speaker diarization. So you separate the speakers, or you can also do a biometrics, voice biometrics, if you have the voice profile available for this about the speaker. And emotion detection is another very interesting area of research where you detect emotions from the speech. There are lots of tools which can detect emotions from text by analyzing the words and their sentiment polarity. For the speech, it is an emerging area, and there are some good databases, data sets like iMocap, which are available to do this exercise. In that, you will find the data sets which have speech, which have text, as well as the video, so that you can combine all the three modalities together and do a deep learning based models. So this gives a spectrum of work that happens. Let me talk about a couple of them now in next maybe 10 minutes. Before I move to the third use case of sustainability. So voice control media player, this was a fun kind of experiment which we did in our organization just to get our hands dirty with convolutional neural network, and this was older work basically, and collecting the data and building an end-to-end kind of application ourselves. So what we did is we envisaged that why not just build some models which can basically trigger based on the words like play, stop, previous, next, volume increase, volume decrease, these 7 commands. And we built a UI which helped us, this was like media player built by us, with we can load some music on it, and we can control the buttons of the media player using the voice commands. And in the background, the model that was used was a convolutional neural network of few layers. And the data was collected by our crowdsourcing application, and it was curated, it was augmented, and whole end-to-end application was developed. So we collected basically around these many utterances for each of the commands. And along with that, unknown and silence also we collected from some data sets. We augmented them with time shift, frequency shift, volume increase, volume decrease, adding background noise. And we landed up with 10 times higher data, like 300 became close to 2,400 and so on. 8 to 10 times we were able to augment, and we got a very good data set which was utilized to train this convolutional neural network, which outputted just 7 class and an unknown or silence. And this was basically utilized to trigger the application. Basically, you can also do this fun experiment in your institute as a course project, and see whether you are able to integrate that with your mobile phone. So while you are jogging and all, you can basically control your applications or the media players there, right? And you'll have to do certain steps here. Like once you get the speech data, you will get a sequence of utterances. Like you'll get play. After that, the user may say pause. After that, the user may say next. So you'll have to use a voice activity detection and clip those commands wherever the command is there, and try to identify those commands by using the MFCC features and the CNN model, and just see whether you are able to accurately recognize the commands, and then control some kind of a device or a media player or anything. Like you can build something like the keyword spotting for Alexa. So we got very good accuracy here. And this is just a confusion matrix of different commands. It was failing for some time, and this was done by very rigorous kind of a test. So we also had the test engineers to do the test for us, and we summarize all the results in this publication, which you can refer to. And one very interesting finding was that in less noisy environment, with respect to the noisy environment, we got higher accuracy, like 69% accuracy for the less noisy. And in noisy environment, it was overall 50. But when we broke it down from in the less noisy, in loud, medium, and low, the louder voice, we got accuracy of 82, which was higher. And within less noisy and louder, if you look at this left-hand side plot, which is a less noisy, and the first bar chart cluster is louder. So in this louder, if you have spoken with a slow speed, which is the 91% accuracy. So basically, we concluded that utterances which are spoken slowly and which are spoken louder and which are spoken in a less background noise, they were detected with very, very high accuracy. And this is very intuitive with respect to how we also hear it, right? As a human being, we intend to detect it very accurately if we, get utterances in a similar kind of a fashion. So this was very interesting insight. All right. So with this, I will just move to the next use case. On the speech, I'll skip again a few slides, but if you look at the end-to-end kind of a prediction pipeline, right, you will have to, if you want to do a speech to text, let's say, you will receive the audio, you will do lots of, pre-processing of speech and all. You will use the trained AI model to predict. Once you get the predict, you will collect it back in the same API. And then you will predict the output, and you may have to do lots of post-processing on it, like include the punctuations, include the capitalize some text, correct some words. So there will be lots of natural language processing that will happen, or text processing, which may have their own AI models. And there might be a step of human validation to get you the text output, which is of very, very high accuracy. So this is what is followed in industry as a practice. Models may be giving you the accuracy of 95% or 92%, but after NLP and human validation with more intelligence, you may be able to reach up to 99 to 100%, which can be delivered to the industry on the text transcripts part. Okay, now let me show you one end-to-end, case study of contact center management using integrated speech, NLP, and OCR kind of a technology. Right, so this was a automobile insurance client from the United States, and they came up with a problem that they have thousands of audio files of conversation between agent and the customer, and they wanted to evaluate that, analyze those conversations. And they also had some hard copy of the conversations because they were interacting with another vendor earlier, and they used to give them the transcript, which was manually done, and in a hard copy. So we have to do basically OCR also to detect the text. So this was a use case. What we did was we built two different integration pipelines. One was on the call center audio files, which were processed through AWS speech transcription service, as well as the speaker diarization service. Then the both were combined together because you will be able to now understand who is the agent and who is the customer. Okay, and associate the timestamps and the text for those two speakers. Then we did sentiment analysis by detecting what is the sentiment of the agent and the customer on their speech and text. And then we did entity detection for the insurance use case. And this was given in the analytics dashboard. And similarly, there was a image OCR analysis pipeline, which was also given in the analytics dashboard. So let me just show you a 3-minute video to demonstrate this tool. So you can see that there are records are available on the dashboard, and we are just searching a record. We can see the record, and we can.
Good evening, Kingswood Apartments. This is Alex. How may I help you?
Hey, yeah, I'm in apartment 104 on the first floor. I'm calling to complain about my neighbors.
Okay, what seems to be the problem, sir?
It's very late. I just got my newborn baby to sleep, and they're being loud again. I brought this to their attention several times, but they never stops.
Okay, I'm very sorry about that. Just let me take down your contact information. I'll contact the landlord right away to get this all straightened out.
You can see a person has been detected as intent recognition from NLP. This is the date. Then you can see the sentiments are also there, neutral, positive, negative. You can basically select some audio files and process them as batch processing, or they can be triggered automatically based on some scheduler. And we get a confidence score also, which helps us to understand how accurate is the result, and we analyzed that accuracy was very highly correlated with the confidence score that we got from AWS Transcribe. This was the OCR one. The transcripts which are available in the hard copy, it got converted to the text again by using AWS Tesseract. Again, you can do the OCR files which are available in image format, batch processing, and the results will be available again on the dashboard once they're done. So it's processing right now. You get a confidence score and you can go to the results. You can see it is converted. There is the agent validation. So it's not 100% accurate. So we need to have a manual intervention also. There might be some words which are low confidence. They can be highlighted and they can be corrected. And finally, the pricing was also required by the customer, so that how much they have spent on these services, because it is charged on usage basis. So it tells this much dollar you have spent for 71 minutes of the audio file. And the reports can be extracted and shared. Similarly, you can have OCR analysis, which can be extracted in the reports format. Okay, so this is on this particular use case. Before I go to the sustainability initiatives now, if there are any questions, I'll take a pause for a minute.
Any questions at this time to the speaker?
And put on the chat or.
Yeah, you could also type them on in the chat. You can take even now or even later. So please feel free to kind of come back with questions.
All right, so let me move ahead then. If there are no questions, you can ask anytime in between on the chat as well, and we'll take it up in the end. All right, so move to the AI-based sustainability initiatives, which is very important topic today for greener tomorrow. What has happened in last few decades is we have exploited the natural resources significantly, right? So the plastic was invented and it was basically used even in the places when it was not required. It was a good invention, but the way it is exploited today, it has created really climatic concerns. So and looking at the emissions that are coming out from the mining kind of industries, as well as power generation, they are humongous. So all this requires and the water, there is a challenge with the water bodies. Water bodies are getting dried out. So there are lots of areas of focus, and industry is thinking very seriously on all these areas. If they are into the chemical manufacturing or mining, utilities, agriculture products, or health and public sector, all these industries, they will have to comply on certain laws so that they will meet the sustainability development goals, which are defined by the UN. So under this area, so Accenture is also helping clients to achieve their targets towards net zero emissions, and internally we are also working towards the net zero emissions mission of utilizing the renewable electricity 100% by 2023, and optimizing on the transport or switching towards smart travel options like electric vehicles and so on. The other two areas which are very important are the waste management and the water security. In waste management, I talked about the plastic waste. That's a big concern. E-waste is another big concern. Again, there will be a waste which will come from the renewable electricity generators like solar panels and all after their lifetime functionality is over. How we are going to deal with that? One has to, ponder and come up with the material which will lead to the sustainable materials in that case also. And the biomedical waste management, we see that everyone is having, so many masks, gloves, face shields today due to this COVID infection, and that's generating a huge amount of waste in the healthcare industry, right? What is the mitigation plan for that? So all these are very important topics, and circular economy is going to touch across all these areas from cultivation of raw material like cotton to generation of fabric, how much is the carbon emission, and to stitching, what is the wastage in that, and to finally, the lifetime of basically apparels that we wear, right? Do we really need so much that we really, purchase? How can we, manage that? How can we make a paradigm shift in the consumer behavior, right? So these are very important areas in which we are working on. And I'll talk about a couple of use cases in these directions. The first one is a smart coal stockpile, in which we worked on, and we started working on this idea a couple of years back. The business challenge here is there is a many times the combustion or the fire emerges in the coal mines. Okay, and it creates lots of environmental pollution by release of the carbon monoxide and hazardous gases, which destroys, lives in the nearby villages and also the workers who are working in that mine. And there is a lives and revenue loss. That's a major loss in terms of monetary loss also. And as I said, there is a safety hazard. And how it actually emerges is you can see in the coal mines, they will pile the coal, which is collected in very big piles, right? And before it gets transported to the thermal plants for generation of the electricity, it is lying there for maybe days and months, sometimes because of not planning of supply chain and so on. That leads to the heat which it generates because of the exposure to the sun continuously. That leads to change in the temperature, and it starts catching the fire, and that leads to the flame of nearby coal stockpiles also. So it's very important to detect how much is the coal stockpile in the mining kind of area and how soon it should be shipped. Or if there is a risk of the combustion, then you should basically mitigate that risk by water spraying or spraying of some, taking some mitigation actions, right? So on this, we have a paper and a patent. Feel free to go and look at this paper, which talks about how do you detect the coal mines and the coal stockpile and distinguish it from the water bodies, which was published in the remote sensing conference. But the idea here really was that we envisaged to combine the multispectral aerial images collected from satellites or drones, combined with the real-time sensor data, which would be collected through the nearby sensors available or the weather stations, and combine that with the static parameters of the coal, porosity and all, which defines how soon it will catch combustion, which was fed to the deep neural network-based models like UNIT and LSTM to detect or predict and forecast spatiotemporal risk of the combustion. Okay, and this was supposed to be, given as a dashboard or variables or automated control system to the mining industry. This is a model that we developed. We collected lots of historical data, and we manually actually marked lots of mines on the map, and we used this as a training data to build a classification model using this UNIT, which is a deep neural network based architecture having so many layers, and the output will give you the recommendation even with a very small data set, because it's very hard to get very large data set in this scenario. So you have to manage with a small data set. So let me show you a small video on this work.
Storage of coal is done mostly in form of open coal stockpiles, which are found in coal mines, thermal power plants and steel plants. These stockpiles are prone to spontaneous combustion, which arises due to oxidation at low temperature, microbial metabolism, absorption and desorption of water. Spontaneous combustion in coal mines is a major problem worldwide, resulting in huge monetary and natural resource loss. Around hundreds of million tons are lost due to fire incidences throughout the world. Further, release of carbon monoxide due to combustion is dangerous to human health and also contributes to global warming. Currently, plant operator conducts manual survey of stockpile. Parameters such as temperature, moisture, etc. are captured to identify combustion in the stockpile. Our team comprises of members as AI scientists, developers from AI capability, and mining industry experts from CNRIG. Together, they bring the domain expertise and artificial intelligence techniques, making the solution beneficial to the client. In Smart Stockpile Solution, we focus on preventive measures by advanced forecast of combustion using artificial intelligence approach. We leverage satellite images along with sensor data for training deep learning models. The solution focuses on localization of coal stockpiles from satellite images, which help to automate the entire process of the prediction of spontaneous combustion in the stockpiles. Step 1 involves data collection, which includes satellite images and coal properties. Step 2 involves localization of coal stockpile and feature extraction. Step 3 involves merging data collected from different data sources. Step 4 involves training and validation of deep learning models. And Step 5 involves integration and deployment of the solution. This is user interface of Smart Coal Stockpile. The pinpoints on the map show the location of a coal-based industries tagged with the organization. We can select a mine of our choice and it will redirect us to the page which will showcase the properties of coal along with weather parameters. Now, user can choose to locate stockpile, which will then highlight the mine as well as the stockpile in those mines. The map will then display the time series variation in land surface temperature for the selected stockpiles. Then, forecast feature will enable us to see the histogram of land surface temperature, NDVI, and features from the sensors. There, charts will display forecast of risk levels in stockpiles against which the user can perform required mitigation activities. Based on prediction, it will create color-coded geofence based on risk level and alert nearby mine workers about the danger. Geofence will act as a danger zone in which the entry of mine worker will be prohibited. Geofencing can be utilized on wearable devices such as a smart band, which can indicate danger by raising an alarm to the mine worker near a high-risk stockpile. Current dashboard can be integrated with a mobile or a tab app, which can be easy to operate from a remote location by a supervisor. Drones can be used for gathering images using multispectral cameras for higher accuracy. Further, we would like to enhance the technical architecture for extending this solution to underground mines. To conclude, our smart stockpile solution will make coal stockpile management economical, safe, and environment friendly.
Great. So this was a use case, and I think we have last 8 minutes. So I have one more use case which is very interesting to cover, which is on the renewable electricity. So I'll very quickly show you that, and then we can open up for the questions. I can see there are some questions coming in. So this one is on the renewable electricity, which is being consumed in Accenture facilities, multiple locations in India as well as globally. And we started this exercise 1.5 years back, and in last 1 year we got very good results here. We use AI models to increase the utilization of the renewable electricity, which has led to a reduction in the carbon emission as well as cost saving as well. Okay, so again on this, let me show you a quick video which is very self-explanatory. and then we can open up for the questions. In a moment.
What do you measure?
I hope it is audible and can see it.
We can't see anything. Also, we can't hear you.
Oh. Can you see it now in small screen? Oh no, I'll have to reshare maybe, I think, because I shared a presentation only. Give me a moment.
Yeah, we can see now the.
See green. Okay.
Yeah.
Climate and energy solutions.
Is it audible?
Yes, yes.
Okay, let me play from the beginning then.
As per the Center for Climate and Energy Solutions, globally we produce around 35 billion metric tons of CO2 with fossil fuel-based electricity contributing 40% of emissions. Greenhouse gases have far-reaching environmental and health effects. They cause climate change and also contribute to respiratory diseases. In India, Accenture facilities are powered by a combination of conventional and renewable electricity sources. The inclusion of renewable electricity is aligned with our global commitments towards RE100 targets. Currently, green power contributes to 42% of our energy demand, achieving an average monthly reduction of 6,000 tons of CO2 emissions. With 100% green power, we would be able to reduce an additional 8,000 tons of CO2 emissions per month. To achieve this target, we propose AI-based sustainable energy management solution, which will result in higher cost savings and environmental benefits. Multiple teams including Accenture Workplace, green power generation companies, and data science have collaborated in this initiative. Here is a high-level architecture of the proposed solution. Input data from various sources are fed into the AI engine, including employee swipe data, daily meter reads, weather and seasonality. The engine comprises of ML models to forecast occupancy and energy demand, which will help to plan activities for greenhouse gas offset. This application can be used via an interactive interface where the workplace teams can analyze historic energy trends, forecast demand, place order for renewable electricity with green power vendors, get suggestions for greenhouse offset activities such as procurement of renewable energy certificates, RECs, tree plantation, generation of in-house green power units. With this AI-based model, we were able to increase share of renewable electricity from 81% to 88% within 5 months for 4 of our facilities. In future, we plan to scale up the development of these models to increase green power consumption at other Accenture locations across India. Further, we will also add more sustainability functions like carbon offset recommendations and demand-side management capabilities, thereby contributing to a greener tomorrow.
So let me share back the presentation. And so with this, I'll just conclude. What you'd have noticed is solutions to many of the problems. It requires multiple technologies. Many times one technology will not do. You'll have to combine them together. And AI application, you would have realized that to build AI applications at scale, you will need teams having team members from different areas of expertise, like business analysts to architects, data engineers, AI scientists, and developers and engineering team. And finally, domain knowledge is very important. So don't let it go, and always stick to your domain that will come handy even if you're working in the field of AI. Along with learning AI, if you have the domain knowledge, that will become a very critical niche skill that you can possess in building important applications. I have team members from mechanical engineering, from energy sciences, and so on. Apart from electronics and communication and computer science, they all play their own individual role in building right applications. So with this, I would conclude my talk, and thanks for your attention. And let's take if there are any questions.
Yeah. So thanks very much, Dr. Bhushan. So now the talk is open for questions, and yes, we do see quite a few of questions. So let me, if there are Zoom users, you could also unmute yourself and ask the question. I see Professor Vivek Datar has a question.
Can you hear me, please?
Yep.
Okay. So my question is, what is the development in helping people converse in different languages? I mean, there is one person talking in, let's say, Telugu, the other guy is in Hindi, and how can they converse using AI?
Yeah, so basically there are video translation or audio translation assets, and there are mechanisms to do that. So we have built our internally also using, you can very easily use the cognitive services from Google. So Google provides speech to text from most of the languages in India as well as the foreign. So let's say a Japanese individual wants to communicate with English speaking individual. So for Japanese individual, we'll have to do Japan to the text, speech to text first of all. Once you have the text, then you do a translation from text, one language to other. So that will be Japanese to English translation. And the English translated text can be, either played as a speech back by using text to speech, or it can be displayed as a chat.
So does that happen in real time, and has it been used?
It happens in real time. Yeah, it happens in near real time, I would say. There would be definitely some delay of half a second or 1 second, but the idea is to integrate the service very optimally here, so that we reduce that delay. Use high powered GPUs so that the delay is not intelligible. But yeah, it is feasible. And the other thing, the research which is going on is directly in the speech, translate the language, but it is in the research phase. So if I'm speaking in English, it will translate to some other language, like let's say Bengali or Japanese, by using end-to-end deep learning based models, where the models are trained to give you speech as output, not text as output.
But can that be done on a smaller device, like let's say a mobile eventually? So
it can be, yeah, because nowadays mobiles are very powerful, and the TensorFlow and all, if you're building, they will have the lighter version of it, TensorFlow Lite, which is for the embedded devices. So lots of models. In fact, today in our mobile phone, the Google speech to text works. Even if you switch off your internet, the Google speech to text works.
Thank you.
Yeah, I think there was one more related
question. Yeah, we will. Yes. I'll take Sandeep Juneja. Sandeep, do you want to ask a question yourself?
Yeah. So yeah, Bhushan, I joined late, so I saw your coal presentation, coal fires detection and all. Whenever you kind of say that, okay, technology can be used to do these detections and save, maybe prevent some of these fires, how do you measure effectiveness of it? Can you like do some kind of back testing, say that if we had done this maybe last year, we would have caused so many percentage of fires or something? Can those kind of analysis be done?
Yeah, it can be done, but we have not done that.
It's
but
hard
it can be done because there is some. Also, the problem here is in this kind of industry, some out on the media. Okay, so the actual data many times you don't get of the actual instances of the fire. We got some media reports of the fire from some locations. Based on that, we backtraced and evaluated the data, and we were able to say that with satellite imagery, you can maybe do the detection, or with drones. Yeah.
Okay.
Okay. Alak, you had a long question. Do you want to ask yourself, or you want me to read out?
I can ask.
Okay.
So you have shown examples of speech to text.
Yeah.
So I think this must be a fairly old thing that's been going on for a while. But
Yes.
I have a specific situation where, as a user of the TIFR archives, I have found that there are lots of recordings of our institute's former members, and some of these recordings, if you are trying to hear it sitting at the archives, it consumes a long time, and so it's
Right.
much more useful to have them in the text format.
Correct.
But some of the the human generated transcripts are not of very good quality, and there are lots of issues because of specific speaker related pronunciation or formulation and articulation issues. Can these be improved by the AI services? And for example, at what cost? A typical interview of a person may be an hour-long one, and there may be some members who were interviewed several times, and there may be of the order of 20 to 30 such
Yep.
interviews over the years. I'm just asking this question only as a user and not anybody.
Yeah, it can be definitely improvised. So today we have lots of cognitive services from Google, AWS. They are definitely available. And I believe NPTEL recordings, if you have seen, they have lots of recordings. They have the transcript and they are done through Google, I believe, Google speech to text. And you can definitely learn. And there are lots of open source models also, which are emerging today. Like Deep Speech 2 is the one, another is the Wave 2 Vec. That is pre-trained on thousands of hours of data set, and they have potential to get customized to customize based on the data. So if you have some human annotated data set, you can definitely do the acoustic model training and the language model training to make it more and more accurate for your corpus. And it always helps to customize and fine tune the model for the corpus on which you want to really use it for inferencing. So that is feasible. One can start with either with cognitive services if it is okay to use those from the Googles and Amazons and so on, or one can start with open source models also and do those transcriptions. I hope it answered your question, but yeah, maybe we can also connect offline if there are if you want to have some specific discussion on how this can be done, and we can connect it.
I see another question from Saishta Khanam, I think is her name. It says, in smart coal stockpile monitoring system you developed, any challenges still there in the improvement of a system?
Yeah, there are lots of challenges. So we basically developed a POC, and the major challenges are on the deployment side, where you will have to actually go to the site and deploy all these systems and get the real data so that your models become more and more accurate. So I would say that's one of the major deployment kind of a challenge. On the technology side, we were able to classify between water bodies and the coal mines and the coal stockpiles. The accuracy we can basically improvise by moving from the satellite imagery to the drone-based imagery, and if you can increase it to the hyperspectral cameras. So again, these are some advanced areas in which one can do the research further on.
Okay, thank you for that. Are there any is someone trying to? Are there any questions? Any more questions to the speaker?
Yeah, I had a question.
Yeah, please go ahead.
Okay, my question was, is there any example where AI has helped the agricultural sector? And significantly, so that the farmer has said that yes, if it were not for this, I would have benefited in so and so way.
Yeah, on the agriculture side, I believe AI has major scope. Maybe I don't have the live examples with me right now. But in my earlier engagement with TCS Research, we used to work on the M-Krishi application where there was a, lot of usage of data science-based models for agriculture. But I believe that now I think it can help farmers in terms of insurance schemes, because you will have the access to the satellite imagery from time to time, which is also available free of cost, almost free of cost. So that can help us to investigate whether farmer has sown a particular crop and at what stage that is in. And AI technology is quite matured. You can do the crop classification. You can do the classification of different stages of the crop. And you can do a lot if there is any disaster happening on the farm because of some natural calamities that can be actually detected, and the farmer should get benefit from the insurance companies, and that's more ethical also. I think that should happen definitely. And I think on organic cultivation side, AI and blockchain together can bring in lots of traceability in your produce. So as a consumer, if I'm producing certain vegetable or something today, how can I reduce the cost of, or how can as a producer I can reduce the cost of certifications and all, so that consumer knows that the produce is safe to consume, whereas it is not too cost heavy. Today when we go for buying organic produce today, it is like almost 2 to 3 times
Yeah.
expensive, right? Ideally that should not happen. It should be available for all masses. So I think that's another area of intervention where AI and other technologies can help, like blockchain.
What about productivity? Because one of the things about our agriculture is that our productivity is very low compared to many even Asian countries.
So on productivity, I have another point of view. I have recently, I'm entering into a permaculture kind of a approach, which is a natural cultivation scheme, right? But we have been told that our productivity is less. But if you see our productivity of wheat and some crops like rice, it is much more higher than what we actually need as a consumption, right? But maybe there is a socio, political angle over there on the productivity side. But I think more than productivity, what we need today is a variety. We need multi-cropping. We need more and more variety, which is getting lost, and we need more native seeds, the organic seeds. We should pay more focus on that, the natural cultivation, rather than productivity. Productivity will come.
I guess Nadi, since he's talking about the productivity per se, I mean, of course, this is not just only the AI backend part, but also the smart sensors, which are actually bringing a lot of data on the plant phenotyping, looking at the structural, looking at the temporal and volumetric data on the plant per se, and also the let us say number of parameters from the soil nutrients and so on. I think that is kind of okay. So it's not exactly just all attributed to AI, but I think a number of advances that you have on the let us say wireless self-organizing networks, sensors, which are bringing this data, which you mentioned early part of your talk. But I'm sure the architectures that are working out, looking at, that's what sometime you also mentioned about insurance in some way, able to predict the crop growth and pests and so on more accurately and more ahead of time probably is also helping farmer, not only mitigating the agricultural costs, but also probably looking at things which are, the financial losses, etc., are kept to a minimum and so on. And the other big area these days coming closely connected with agriculture is animal husbandry, which is also, I think, is one of the biggest beneficiary in terms of the combined field of IoT, which includes, of course, sensors and the data science or AI. Yes, these applications seem definitely something which are actually solving the real life problems, as you mentioned earlier. From 80s or late 80s or even 90s to 2000, the big paradigm change in terms of getting the computation coming in the picture, big data coming in the picture has really changed. It's a big, I think, a gear change for AFP. So They're very nice, very real examples of case studies, use cases that you mentioned. They're very nice. Yeah, that's right. Okay. So any other questions to the speaker? Any more questions? Anything from? Oh, okay. There's one question that was asked here. How do you identify that AI will be the optimal solution and not anything else? Yeah. So if you identify a problem, how do you know that the AI solution is?
So what happens in AI is typically when we train the models, you see the training loss, the cost, as well as the validation cost. You keep on training till you reach a point where training curve is reducing, but validation curve should not start increasing. When it starts increasing, then maybe you're doing a overfitting kind of a thing. So there are some practical tools which can help you to understand where you have to stop the training, or how do you do the hyperparameter tuning so that you arrive at near optimum kind of a solution. And another big challenge in AI, what we did not discuss today is the explainability part, responsibility part. How do you explain your predictions? Maybe with statistical techniques and other type of models, it is easier to explain, but AI, that's a bigger challenge to explain your predictions and decisions. But yeah, good question. I think it's important to train your systems till you achieve the optima.
Yeah, you want to say a line or two about the general platforms that, let us say, like students or maybe entry-level faculties can take benefit to kind of start working on some of these systems, which are, okay, maybe they address the small domain problems, but still it will take them to get down to the technology at large at a later stage. So are there some, let us say, open source tools or platforms which will allow?
There are many open source tools, but they are like specific to different areas. Like speech, it will have its own, as I said, couple of models like deep speech 2 and where to act, they are emerging from Facebook. They are open source. But lots of information I think you will get on the Git repositories, and the challenges, Kaggle challenges. So with that, I think you'll be able to see lots of open source models that are released for public. The students can, and you can feel free to reach out to me if there are any interesting ideas on sustainability, and if you want to work as a volunteer or together on any kind of ideas, I'll be happy to discuss. And
so I ask this in the context because there are a large number of students I see on the call. So quite often in the academic institutions where the undergraduate and postgraduate students are the big resource, I would say. And so if there are some problems that can be tackled easily and can be published, obviously it will be a great boon, not only to the student, but even to the faculty as well. So there could be such problems, which are sometimes people tend to call them as low-hanging fruits, but nevertheless, there's something, a nice entry into getting into the technology. So that was my motivation of asking this question. So somebody was asking if you can share your contact, if that is possible.
I can share.
Yeah. Meanwhile, there is also a question from Naveen Arora. If you would like to ask question yourself. Okay. Otherwise, let me. Okay. Mike has problem. All right. I think many of us are students that are just being introduced to the concepts ML and NN by self-study. So it was.
So I think, yeah, Coursera on this question. I think Coursera, there are lots of courses from Andrew Eng that can be a very good starting point for all of you who are starting in this journey of. There's a course on machine learning, and there is a specialization on deep learning with 5 courses. So that should be the first step to go through those courses and do those assignments. And from there, I think you'll be able to pick it up very easily if you're completely new.
Okay.
Okay, so I think there are no other questions.
Can I ask one question?
Yeah, sure.
Yeah, we can't hear you.
Sorry, sir. Sir, actually, I have just started my PhD work. This may be out of time, but I've started working on image processing. So, can you suggest anything? Like you are working on so many things. So, can you suggest anything like where, like I have found one thing like you are working on satellite images. So, in a similar way, like some challenges, if you can tell us, that would be useful for us.
Yeah, so mention some challenges which in the satellite imagery, like you can analyze data coming in from drones as well using hyperspectral cameras. But more or less, a good way to start your research is, go through lots of research articles and literature. And once you understand the broad area of research, you deep dive into some publications. And then I think you will be definitely be able to pick up your own problem statement very easily. But no, there is no shortcut, I think, to that. One has to do that kind of exercise themselves to get to that right problem statement in which you would be interested for next 3 to 4 years and do a deeper research.
Okay, sir. Thank you, sir. Thank you.
Thank you. Thank you very much. So I guess there are no more questions. So let me once again then thank Dr. Bhushan for this nice talk, and it also been quite interactive because there are lots of questions obviously on this emerging field. Thanks very much, and also would like to sincerely thank the Vidyavardhini College of Engineering and Technology, Dr. Vikas Gupta, Dr. Sunaina Jadhav, and also IEEE Bombay section, the Technical Professional Activities Committee led by Dr. R.N. Patel. So you all have been made this talk possible. So thank you once again, all of you, and thanks once again to the speaker for very lively.
Yeah, and thanks, sir, and thanks for the invite, and thanks to all the students. And you're the future for tomorrow. So all the best for your studies and the next steps. Thanks all.
Thank you.